Sciencey, we do best. Missy helps you pass the test. Whee!
Hello and welcome to the how-to series of science videos with me, Miss C. In these videos, we'll tackle the topics which at the moment make your brain hurt and make them less painful. In this video, we're going to focus on how to solve or how to determine the limiting reactant. So what's this all about? So a chemical reaction finishes when one of the reactants is all used up, leaving the other reactant nothing to react with. The reactant which is all used up is called a limiting reactant because it limits how much product can be formed. The reactant which has not been used up is in excess, i.e. there's more of this reactant than the other one. So actually, how do we go about doing this? Well, guess what? We've got a simple process with some simple steps. So let's have a look at them. So firstly, you write out the balanced symbol equation. Step 2, you work out the formula masses of the substance of interest. Step 3, you work out the number of moles there are of the substances that you're interested in and the ones that you know the mass of. Step 4, you look at the mole ratio of the reactants. Step 5, when you've done that, the reactant with the smaller number of moles is the limiting reactant. So let's have a look at a worked example to see these steps at work. So we've got a mixture containing 1 kg of aluminium and 3 kg of iron oxide. We've got a balanced symbol equation and we're asked to show that aluminium is the limiting reactant. Now in this question you've been given the relative atomic masses, so you don't have to look them up on your periodic table. So let's follow the steps and work out which is the limiting reactant. So balanced symbol equation. By the way, in the exam you don't actually have to write it out, but you could just underline it on your paper. Then you're going to work out the formula masses of the substance of interest. We've been given them, the relative atomic masses, so we can work out the formula masses. Then you've got to work out the number of moles there are of the substances that you know the mass of. So we know the mass of aluminium, so we can work out the moles of that. And we know the mass of the iron oxide, so we can work out the number of moles of iron oxide. And there you can see that we've got 37 moles of aluminium and 18.75 moles of iron oxide. So, step 4. So what we're going to do now, we're going to look at the mole ratio of the reactants in the balanced symbol equation. So remember, the coefficient in front of the substances is the number that we're looking at. So from this balanced symbol equation, you can see that twice the number of moles of aluminium react with the number of moles of iron oxide. We've just worked out that we've got 37 moles of aluminium and 18.75 moles of iron oxide. Looking at the mole ratios, if we multiply the amount of iron oxide or the number of moles of iron oxide by 2, we get 37.5. And we've actually only got 37 moles of aluminium. So aluminium has the smaller number of moles, so therefore aluminium is the limiting reagent or the limiting reactant. The word reagent and reactant, you will hear either of those words or see either of those words on your exam paper. So if you do, you know it's 2 words, but it means the same thing. Okay, so let's look at worked example number 2. So, how much aluminium chloride is formed when 2.7 grams of aluminium is reacted with 9.125 grams of hydrochloric acid? So, let's follow the simple steps. So, we've got our balanced symbol equation. We're going to work out the formula masses of the reactants. And now we're going to work out the number of moles there are of each of the substances that we know the mass of. So we can work out the number of moles of aluminium and we can work out the number of moles of hydrochloric acid. So you can see that we've got 0.1 moles of aluminium and 0.2 0.25 moles of the hydrochloric acid. So let's look at step 4 and 5. So step 4 is when we look at the mole ratio. So you can see from the balance symbol equation, we've got a ratio of 2 to 6, which we can simplify to 1 to 3. So you'll need to put your maths heads on for this and think about ratios that you've learnt about in maths. So again, the reactant with the smaller number of moles is the limiting reactant. So in this particular reactant, or reaction I should say, we've got 0.25 moles of hydrochloric acid and 0.1 moles of aluminium. So looking at the mole ratio, this tells us that the aluminium will run out first, so aluminium is the limiting reactant. Now, we're going to use the mole ratio to calculate the mass of the product. So, again, we've got a mole ratio of 1 to 3. And again, we've got 0.1 moles of aluminium and 0.25 moles of hydrochloric acid. So we've now got the formula mass for aluminium chloride, which is 133.5. You divide 0.25 by 3 because of the 3 to 1 ratio or the 1 to 3 ratio to get the moles of aluminium chloride. Now, the mass of aluminium chloride is equal to the number of moles multiplied by the formula mass. So let's do that. So we've got 0.0833 moles multiplied by the formula mass, which we've already worked out to be 133.5. So we end up with a mass of aluminium chloride of 11.12 grams. Now, as you can see in this particular example, there's been lots of things that we've had to work out. So it's really important that you show all the steps in your working out. And, do that and you'll pick up all the marks available. So, worked example number 3. In an experiment, 0.5 moles of hydrochloric acid was mixed with 0.5 moles of magnesium. Use the equation to show which reactant is the limiting reactant and which reactant is in excess. So let's do this one. Only 2 steps. So we've got our balance symbol equation, and looking at the balance symbol equation, we can see that 1 mole of magnesium reacts with 2 moles of hydrochloric acid. Magnesium is the limiting reactant and hydrochloric acid is in excess. There's only 2 steps involved in this particular question because we've got the same number of moles of each of the substances of interest. So when that happens, you just go straight to the mole ratio, look at the mole ratio, and obviously the smaller number points to the limiting reactant. Voila! Genius! So, I hope you found this video useful. If you have, please give it a thumbs up and hit subscribe so you'll be notified when more videos are added. If there are any other calculations in biology, chemistry or physics which make your head hurt, please pop them in the comments box and you may see your request made very soon.
All things sciencey, we do best. Missy helps you pass the test. Whee!